Hi everybody, I'm Maria. I'm a research assistant in the University of Cambridge, and today I will talk about probabilistic programming. So firstly, I'm sure I don't need to spend a long time convincing you of the importance of machine learning today, simply because it's everywhere. We have huge applications in robotics, statistics, biology, finance. And partially, work in those areas was possible due to the introduction of probabilistic graphical models and later probabilistic programming languages that help describing them. In this talk, I will say more about what probabilistic programming languages are, how they differ from conventional programming languages, and how we address those differences by building an IDE especially for probabilistic programming. I will also mention some results from a user study we conducted to evaluate the software. Okay. Right. So firstly, what is probabilistic programming? Well, let's start with what a probabilistic graphical model is. These models describe our belief about a probabilistic system. So that is what the probabilities of certain events happening are, what are the dependencies between those events, and so on. This belief is expressed as a network where each node is a random variable and each edge is a direct dependency. So, for example, suppose we're flipping two coins once, each one of them, and each one of them has a probability 50% of being heads. So these are the coin 1 and coin 2 nodes over there. Suppose also we are interested in the question, did both of the coin flips result in heads? That's the other random variable or node in the graph, both heads, which has a probability of being true only 0.25%. Now, probabilistic programming languages try to make the description of probabilistic graphical models easier by treating random variables as primitive objects and by introducing automatic inference that can help updating what the probabilities of events happening are after observing some evidence. So, how is probabilistic programming different from conventional programming? Well, first of all, when it comes to conventional programming, we are used to thinking of each variable as something that has a concrete value. So it could be a number, it could be a string, it could be some complicated object, but it has one specific value. While with probabilistic programming, that's completely different. Coin 1 is not true or false or head or tails. It can be either of those with 50% chance attached to each possible outcome. Not to mention that we can have more complicated probabilities such as Poisson or Gaussian, more complicated probability distributions such as Poisson or Gaussian. Okay, so that was the first difference. And the second difference we found was that with conventional programming, or at least when it comes to best practice in conventional programming, we are not used to side effects. And what I mean by that is that if we define coin 1 and coin 2 to be not random variables but normal booleans, right? And then maybe later in the program we assign them to some values, true or false, and then we define both heads as being the logical end between coin 1 and coin 2. If we then change the value of both heads to be false, that doesn't affect coin 1 and coin 2. Coin 1 and coin 2 stay whatever we assign them to. With probabilistic programming, though, that's completely different. Suppose we call a friend, and this friend flips the coins for us, and then we don't see what the individual outcome for each of the coins is, but our friend tells us, okay, they weren't both heads. So we know this, and knowing this means that so if coin 1 was heads, that means coin 2 definitely wasn't. That means coin 1 and coin 2 are no longer independent. So if we do the maths, we see that there is only 33% chance of each one of them being heads. That means that changing the value of both heads, observing that it is something, changes the values of the random variables that define both heads. Okay, so the aim of our project was to design a tool that communicates those conceptual differences. And how did we do that? Well, we did it by visualizations. Here you can see the two. On the very left, there is a text editor in which you can write code in F# and code a probabilistic programming framework in Infer.net. So in this case, the example you see there is what we discussed with the 2 coins. In the middle, you see a visualization of the graphical model that this code describes. And on the very right, you see visualizations of the probability distributions of the random variables. Now, this software is live, meaning that if we go ahead and do whatever our friend told us, so observe that both heads is in fact false, they weren't both heads, what will happen is that the IDE will shortly update the visualizations, and then you can see the changes and how coin 1 and coin 2 now have only 33% chance of being heads. Next is another example, which is actually taken from the user study we conducted. And here the participants were given some kind of textual description of what the model should look like. And they had to see that there is a missing dependency, according to what the model description was in their workbook, between smokes and has bronchitis. They also had to go ahead and change this, find where the problem is, and change the model in such a way that it now describes whatever the workbook says. And after all the changes are made, you can see how now there is a dependency between smokes and has bronchitis. Finally, a bit about the user study. So that was conducted with 16 participants who were given a workbook that introduces them to F#, to probabilistic programming, and to Infer.net. Then they had to complete interleaving exercises and half of the participants completed them using the visualizations that the IDE provides, while half of the participants completed them using a plain text editor. The results showed that the participants who used the visualizations were significantly faster and used significantly less keystrokes. Thank you very much. The IDE is online on GitHub, and if you want to talk more about this or probabilistic programming in general or see a live demo, please come and find me.
Hi, Daniel Ashbrook from the Rochester Institute of Technology. I wonder if you've considered visualizing the variable values or probabilities directly in the code, instead of as a separate graph, or in addition to a separate graph, maybe some tiny little spark lines above each variable or color coding them or something, so as you look through your code, you can see those values.
So you mean without the visualization of the graph? So let me.
Or maybe in addition to the visualization of the graph. So maybe there, you know, if I have an observation and smokes changes, then I might show that on the left-hand side in the code to show the smokes variable changing color, or show that it's somehow changed or somehow has a different value.
You mean like with maybe animation or something like that?
Yeah.
No, we haven't, but that's a very good idea. Thank you. Thank you for the suggestion.
Hi, Kotaro Hara from University of Maryland. It's really exciting work. I had a question about the study method. I maybe missed it, but what happens if the model becomes really big? Like, it seems like the network is not too big, but did it have any effect, or you didn't look at it?
So it probably will be slower, and the bottleneck in this is the Infer.net compiler. So the framework is very slow in compiling a new model. If you only kind of observe values for different variables, then that happens, the inference of what the probabilities for the rest of them happens very fast, but compiling new model is slow, so a very big model will probably take longer. But you still can go and explore, like change the zoom levels and move around nodes in exploring the network when the compilation is done.
Actually, that's a great point, but I meant in terms of human perception, like when they're perceiving the results from probabilistic distribution. Like, was there, I don't know, like plateau in perceiving all the models?
Yeah, I see what you mean. We haven't studied that. We focused on how the software works with small examples and novice participants who haven't seen that before. So how it affects their learning in a way.
Thank you.
One other question, can you create code by manipulating the graph?
No, but it's like future work. It would be extended to do that. Yeah.
Thanks.
Okay, so you mainly had novice users in your user study, and you had a positive effect, a lower number of keystrokes. So I guess they made less errors. How big of an effect would this prototype? How useful would it be for power users who already know about probabilistic programming?
So this concrete prototype, I think, might not be of that much use for a professional infer.net user, but it could be, if it's worked upon, it could definitely be extended. And there is a lot of interest in actually in the Microsoft research group who develops infer.net in doing exactly this, developing tools that support writing probabilistic programs.
Any more questions? Okay, so thank you very much, Maria, and thank you all the other speakers.